Alright, the class has start recorded. Right. Start recording on. Okay, so yang dalam online tu kalau tersangkut bagi tahu mana bagi online tadi. Alright. So semua dah masuk ke? Kita ada Mr. Alvin and Mr. Wan. Okay. So, let's start our class by not looking at Alvin. Right. So, have you remember the names of the stoichiometry, the molecular geometry? Okay. We have a few. Okay. So, pada depan ni I have a few. So, it is purely based on geometrical mana controller ni? It is purely based on molecular geometry. Mathematicians tengoklah and how they roughly organize the molecules as far as possible to minimize precaution. Betul nampak? Yeah. Okay. So these all have names. Okay. Question will expect you to memorize the names. Okay. So we have linear, right? And we have trigonal planar. Okay. Why it is called trigonal planar? Because it is in the shape of and it is in a plane. So I'm saying there's a plane. Okay. Maybe in what plane tak kisahlah. Okay, and we also have tetrahedron. Ini yang the hardest untuk illustrate because kalau kita tengok the shape looks simple. Right? Orang belakang nampak kan? The shape looks simple, tapi if you look properly, right? If you look properly, it's not flat. Dia ada kaki macam tripod, macam tripod kamera ni. Right? Nampak macam dia lain, nampak macam atas ni lain kan? But actually all are symmetrical. Same. Tak ada beza pun. Right? And moving forward, we have trigonal bipyramidal. Why it is trigonal bipyramidal? Because kalau you tengok, it is in the shape of a triangle. Right? And it's called pyramidal because you sambung kan, nampak macam piramid lain. And it's called trigonal bipyramidal because we have two. So we have two pyramids. One dekat atas, satu dekat bawah. Okay. So you can go here. And the simplest one is octahedral. Right. So we have octahedral. Okay. So simple enough. Let's see the type of question yang past paper akan tanya. So the online punya people can click on my camera and look. Baik, saya tutup lampu gelap-gelap ni, jangan mengantuk So in 2013, question number 50. So we have BF5 H2S CS and NO2. Ada blur ke? Nampak tak? You should be able to nampak those molecules. It's PF5 H2S CS2 and NO3. Okay, the question asks you is explain the difference in bond angle. Okay, so pretty much dia tanya bond angle and the pairs of molecules or ion. Okay, so kita akan tengok the geometric shape and dia punya bond angle lah. So the bond angle, by hook or by crook, you have to remember, and also the name, right? So if you nak ingat which one is which, right? Kita tunggu dia buka. So the name, the bond angle is in my slide. Okay, you have to remember. And dah keluar tu. Nampak kan? So okay. So the bond angle, usually for linear we have 180, trigonal planar we have 120, and for any molecules yang dia ada distortion. By ada distortion is we are having lone pairs. Okay, instead of bonding pairs kita digantikan dengan lone pairs. So what you are writing for the bond angle, you don't need to be precise. What you need is just you buat like this, which is less than 120. You just bagi tahu it is less than the original angle. Okay, why it is less than? Kenapa dia kurang daripada? So if you look at here, okay, the trigonal planar. Right? But now it is replaced with lone pairs. Okay, kenapa this angle is less than 120 degrees? Okay, can you figure out any reason why? Okay, kenapa it is less than? Mengapakah? Okay, remember VSEPR? It is valence shell electron pair repulsion theory. Okay, it is in the name that we are talking about repulsion. Okay, we are talking about repulsion of electrons. In this term is what kind of electrons? So we have lone pairs and bonding pairs. Okay, so in lone pairs, okay, what differentiate between lone pairs and bonding pairs? Okay. What differentiate between lone pairs and bonding pairs? Lone pairs, ini dia orang ada dua, dia orang berpasangan, dia orang free untuk dating kat mana-mana gerak. Okay, but now dia orang dah kahwin, right? Dia orang are restricted to their own atoms. Okay, so these electrons, the electron pairs here are restricted untuk pergi ke A dengan X. So they are very close together, right? Itu je tempat yang dia gerak. Okay, masa dia orang dating, dia orang pergi mana-mana, right? So what happened is, masa dia orang, bila dia orang are restricted, the area they orang occupy is smaller than lone pairs. Okay, so bila dia orang dah free, dia orang free masa nak dating, dia orang occupy larger space. So the real reason is the repulsion of lone pair to bonding pair is stronger than lone pair to lone pair repulsion. Okay, tolakkan antara bonding pair dengan lone pair together. So lone pair to lone pair to their repulsion is way less than lone pair to bonding pair. Sorry. Terbalik dia cakap. Okay, bonding pair to bonding pair repulsion is less than lone pair to bonding pair and less than lone pair to lone pair. Okay, so kalau kita have more lone pair, so it means that the repulsion will be higher. Okay, so the angle will be less. Okay, so kalau lah kita ada more lone pair, for example nanti usually around here, the alternative, maybe we have more lone pairs. More lone pairs. So the angle will be very pushed together. So saya nak tulis, okay, instead of 90 degree, buat less than twice. So less than 90 degree. Nanti kita akan tengok. Okay. So that's the introduction. So let's look on the question. Apa? I think dalam language. So for this kind of question, the question will be very nice to you kalau dia dah bagi the molecular geometry. Right? Kalau dia tak bagi, it means that you have to find the molecular geometry by yourself. So apa step nak buat molecular geometry? So we have actually 2 steps je. But each of the step ada banyak. So ingat tak apa ni? Okay, macam mana nak saya gini saja? What's the first thing you have to do? Yes, the valence electron. And then baru you susunkan cari the most less electronegative atom dekat tengah. Right? So, first, let's find dia punya valence level. So, valence level. Kalau example electron, kita boleh pendek. Okay? Valence electron untuk phosphorus and fluorine. Apakah valence electron untuk P? Phosphorus. Yes, sebab dia group 50 kan? Okay, nanti dalam exam you guys nak given periodic table. Periodic table tak repeat. So macam mana you guys nak cari valence electron? Okay, satu you guys dah hafal. Kalau dia hafal. Don't worry, dalam exam siapa buat buku tutorial? Saya tertinggal lah. So dalam buku tutorial or in exam, you guys are given a table of proton numbers. Okay, so from the proton numbers you boleh cari lah dia punya electron, valence electron. Okay, buat dia punya SPDF notation. Right? So fluorine group apa? 70 kan? Tapi ini juga total. Okay, dia ada 5, so kita kena darab dengan 5. So tolong masa saya kira saya. So we have 40 electrons. 40 valence electrons. Okay. 5 lah. Okay. Tahu tak tulisan saya cantik? Alright. So another step on drawing the molecular geometry is we choose which one. Okay. Most of the time it is very simple. Kalau kalau dia yang compound integrate is very simple, you boleh terus cari, right? Kalau most of the time center is atom yang ada satu saja. But most of the time lah. Okay, so this is the center atom, so dia tu je. Make sense untuk letak 5 kat luar. Ini will be the center atom. This will be the center atom and this will be the center atom. Right? In most cases. But we also have contohnya OCN minus. Right? This kind of molecule semua ada satu je, so you tak tahu nak letak mana tengah. So tengok yang mana? Less electronegative ke less electronegative ke more electronegative ke? Yes. So you pick the less electronegative. So you pick which one, and then to ensure that you be center atom betul, you kira dia punya formal charge. Okay, remember kita kira formal charge is based on valence electron. Okay, minus bonding time. And minus half of the bonding pairs, the lone pairs. Then, No, is minus dengan square, kita ada bracket kan? Okay. So in this case, it's quite simple. It is cost versus lah. So macam mana you nak susun? So you can susun like normal. Kalau have more than 4, you susun bagi cantik je lah. Kalau dia ada 4, kalau ada 4 dia punya atom yang kat keliling, dia letak keliling dia 4 keliling je. Okay. Atas, bawah, kiri, kanan. But now we have 5, so you letaklah tepi. It's fine. Okay. So and then you punya structure, what you need to do is the very first thing is you connect the structure. Okay. So you connect the structure. Semua connect ke tengah, sambung kan. So now you kira berapa banyak yang you dah guna. Okay. To make a bond, it requires 2 electrons. Okay. So 2. So kita dah guna 10. Right? 10. We will have 30. So what do we use with the 30? Kita makekan all the atom yang keliling dia octet. Okay? So kita buatkan octet. So isi dia sama juga. Kita isi atas, bawah, atas, kiri atau kanan, bawah. So isi atas 2, isi tepi 2, isi bawah 2. Dah cukup, dah dapat. 1, kita ada 2, 5, 6. Campur dengan yang bonding pair 2. So cukup dapat, right? Okay, sebabkan ada bonding pair tak payah nak bonding pair sini. Okay, banyak lagi 4. So isikan all. Right? So and then kira berapa banyak yang you dah guna. Berapa banyak lah? So you have used 30. So minus 30. So you dah tak ada balance kan? So you punya structure dah complete. Doing structure you dah complete. So but the question do not ask you about doing structure. Okay? You are doing all this work just baru separuh jalan. The soalan ask you about dia punya bond angles and dia punya geometry. Okay? So macam mana kita nak tahu geometry of this? Apakah geometry dia? Kita nak tengok atom yang kat luar ke, ataupun nak tengok atom tengah ke, ataupun selakit tengok mana ke. Kita only look on central atom. That's what it is, dia punya geometry. Okay, kalau kita tengok all these models, only what it takes dia punya kedudukan yang kiri tu is dia punya central atom. Okay, in this term dia ada lubang in that position. Okay, so that's why Higgs dia dekat luar ni, atom yang dekat luar ni saya panggil Higgs. Okay, so this atom dekat luar ni boleh duduk macam tu lah. Okay, so it only looks on the central atom. So we look on the central atom. So what do we count in the central atom to figure out the geometry? Is we look on the bonding pair and the lone pair. Okay, kita kira apa yang ada dekat the central atom. So in this compound we have 1, 2, 3, 4, 5 bonding pairs. But do we have lone pair? Tak ada. So we only have 5 lah. Okay, the total is 5. So kalau 5, this is where you have to remember. Okay, so remember dia punya nama tu. So kalau 5 dia apa nama dia? Yes, it's trigonal bipyramidal.
Pyramidal.
Yes. Piramid yang ada 2, dia bertangkup atas dan bawah. Okay, so this is where you have to remember the shape. Okay, so that's why kalau you nak guna, boleh you can go on. Okay. Because later this, I will ask you to do. Okay. So we have, okay, saya tulis sini ya. So should be trigonal bipyramidal. Okay. One common mistake is salah AI. Okay. Is BI dan GY. Okay. So BI bermaksud dua. Okay. So jangan tulis BY, PY, RA. Okay. Dia punya answer akan salah. So, okay, I'll give you a while. So for now, you punya PSPM may be objective. Okay. PSPM, which is final exam, kemungkinan besar objektif. Tapi not 100% sure yet. Okay. So kalau objektif, you kena pilih jawapan yang betul lah. Okay. Tapi tiba-tiba lah bahagian tukar pula, dia nak buat subjektif balik. So you have to know how to draw. Okay. But just pray that it will be subjective. Because you can earn more marks. Okay. Kalau objektif, you salah satu tu je dah lose berapa banyak marks. Okay. Kalau subjektif, you punya jalan kira pun ada mark. Okay. So you have more marks yang you boleh cover kalau you tak ingat semua. Right? Okay. So trigonal bipyramidal. Macam mana kita nak draw trigonal bipyramidals? Okay. So nak draw dia, we always start dengan central atom. So start in central atom. Now it is phosphorus. So we lukis dulu anything yang dalam plane. Okay, apa masuk dalam plane? Okay, dia dalam paksi yang sama. Dalam axis yang sama. So this is trigonal bipyramidal. Right? Okay, and if you look, right, we can actually masukkan 3 of the molecule in one plane. So this is the plane. Boleh putih ke pula? Hitam kan? Okay. Mana ni? Lagi minyak ni. Okay. Actually kalau you tengok, any tree is one plane. Okay. Apa masuk dengan one plane? Okay. Diorang boleh duduk lay flat. Okay. Nampak tak? It's three atom. So 1, 2, 3 dalam bentuk t-shirt ni dalam satu plane kan? Right? And you can choose any tree. So it means that they have one going up, one going down, and satu, 3 dekat belakang. And apa yang dimaksudkan yang lagi dua dan bukan dalam plane? Kalau you nampak tak? Yang dua ni, satu ke belakang, satu ke depan. Right? Nampak kan? Satu ke depan, belakang. Right? So our challenge now is to represent this on your paper, which is 2D. Okay? Macam mana kita nak lukis 3D papers dalam 2-dimension paper. Alright? So, how we draw is kita draw the one in plane dulu. 3 atom dari. So, phosphorus. And now we are drawing the one in plane and out of plane in terms of wedges and edges. Wedges and dashes. Okay. So the one yang masuk dalam. So I will say this one masuk dalam. So I will look it like this. Okay. I will look it. Okay. I will look it like this one masuk dalam paper, while this one terkeluar kat paper. Kalau awak tengok ini nak cucuk awak, ini is away from you. Right? So the one that it is away from you, we denote it with the wedges. Okay, macam potato wedges dekat KFC. It's right angle here triangle. So right angle macam itulah. So you can lukis it putih dalam, or you can lukis it as you color kat dalam. Doesn't matter. As long as it is wedges lah. So ini yang masuk kat dalam. So dekat belakang paper, right? Belakang paper ke atas. While the one yang keluar kat depan, cucuk awak, we denote it guna dashes. Okay. The way you draw the dashes, the same shape macam you punya wedges. Okay? Macam gambar Adidas. Okay? So kecil depan, panjang belakang, right? And you draw that. So that is you punya geometry, molecular geometry. Okay? So you know the name, you know how to draw, right? But now, the another important step dalam you punya molecular geometry is to tulis dia punya angle. So this one also you have to remember. But how to by two have to remember lah. We actually have two angles. Kalau you nampak, okay, bayangkan ni tadi. Okay. So you actually have angle between this and this, this and this, this and this. It's the same angle. Mana monitor saya tadi? Right. Right. So bayangkan bawah tak ada. So this and this, this and this, this and this are the same angle. Kalau kau ni kau rasa ni angle apa angle between this and this? Yes, 90 degree, right? So it will be the same kalau dekat bawah juga, right? It's the same. It's symmetrical, right? So tak perlu nak buat semua. Just tanda satu dah lah. So it is 90 degree, right? But now we have another angle. Okay. So tadi kita ada 90 degree, right? We have another angle of, kalau if you look at this, okay, bayangkan dia tak ada this. So we have this kind of angle. So ini formula berapa? Yes, 360 divided by 3 is 120. So sama juga, tak perlu tanda untuk semua, just buat 120 degree. Okay, so that's the angle. So untuk just to be safe pada exam, tulis balik dia punya nama and tulis balik dia punya angle 90 degree and 120 degree. Dia ada dua angle. Okay. So I'm gonna give you contoh lah. Contoh kita replace this with a long hair. Apa jadi kalau kita replace this with a long hair? Okay, apa angle yang berubah? 120 degree. Yes, the 120 degree thing should be berubah. Because here, okay, so this is not on the syllabus yet. But actually this boleh rotate. So coba ini. Ni aku pegang kuat ni and dia boleh rotate. So kalau you replace one with a long pair, this long pair, maybe dia tolak, okay, bengkok sikit, but at one point it will rotate and that thing akan bengkok the other way. So this angle will not change. But the only angle yang tak boleh nak rotate around, okay, this, bayangkan this is the long pair, this angle. Right? Bagi mengecil. So apa yang you tulis? Okay, just you tulis less than 1. So, okay, so new angle. It's still 90 degree, still the same, but it is less than 120 degree. Okay, is that clear so far? Okay, and also, but now angle will change since kita juga low pair, dia punya molecular shape pun also change, right? So because molecular shape, okay, we only take notes of bonding pair. Okay, kita bayangkan low pair tak wujud, kan? So apa shape dia? Okay, tadi kita buat tadi. Apa shape dia? Yes, seesaw. Macam mana dia, kenapa dia panggil seesaw? Dia rotate dia lah. Nampak tak? Macam tak? Jadi macam bentuk seesaw. So, you tulis lah, dia punya new shape, molecular shape is seesaw. Okay, so I think that's clear so far. Ataupun ada any question? Yes? Membaris? Ha? Yes, boleh terbalik. You kalau nak letak the dash dekat belakang, boleh dekat depan pun so. Okay. Because it just signifies that this masuk dalam you punya kertas and it's slow and vice versa. Right? It also can turn either way. Right? So this one dah okay ke? Kalau senyap tanda setuju, right? Because we have 3 more molecules. Kenapa sekarang senyap? Pening. Dah bawa malam ni. Right. So, ya, saya dapatkan sikit. Kawan 3 volunteers ataupun nanti saya beri nampak. So we have 3. So what I want you to do is buat dia punya Lewis structure dulu. Okay, and then the next person nanti akan saya panggil lagi 3 orang buat dia punya molecular geometry. Okay. I have 3 very beautifully colored fan. Sekarang semua tiba-tiba tengok meja dulu. You can choose this one. Nak buat dia punya. Apa ke? Saya buat cepat mereka report. Oh, sorry. The easiest one should be left one. I'll give you a hint. And a double bond. The carbon combines sulfur group. Yes. Awak ada jawapan ke tak pun awak tu? Ha? Okay, so choose central atom dulu. And then you just susun je dekat luar. Okay, thank you. Thank you, Khairil. Okay, thank you. Okay, nanti you nominate seorang untuk buat dia punya structure Okay, so see. Okay, slowly I will buat. Kalau in this letak kiri kanan. You ni daripada you letak dari kiri ya. Okay, so now kita dekat luar. Ada berapa ni? Kita balik kita tak. 6 kita dah 12. Jadi awak dah tahu lupa tambah. Tahu lupa tambah ke ni? Okay. This is the total, right? Okay, so if you look, kalau awak tengok, ada yang tak cukup octet lagi. Nitrogen cukup tak octet? Okay, our goals of drawing with octet. Yes. Okay, but you are forgetting one thing. Okay, this is ion. So macam ni kita nak. Yes, octet. Okay, so our goal is kalau boleh, we want to make it as octet as possible. Okay. The only reason kita tak boleh buat octet is either tak cukup elektron ataupun kita terlebih elektron. That's the only thing. Okay. Whether kita ada incomplete octet ataupun expanded octet ataupun odd number. Odd number kalau ganjil lah. We have bukan long pairs. Okay. So selagi kita punya Lewis structure is not octet, okay, semua komponen tak octet lagi, kita tak boleh rest. Okay. So we need to make sure all of this are octet. Okay, sulfur dah octet kan? Right, correct. Okay, sulfur also dah octet. But carbon octet ke belum? So how do we make it octet? So we make it double bond. So apa kita nak buat double bond ni? Okay, so what we do, yes, we take any lone pairs. Here, doesn't matter, all are the same. But using pyramid tepi lah. So we take the lone pairs and we turn it into a double bond. And dah tukar ke double bond tu buat lah lone pair. Jangan nak tinggal dulu lah. Okay. Okay, and then you dah check this one dah ada 3, still not octet. So what you do, ambil lagi sebelah. Ambil. Dah you octet. Okay. Same case dengan sini. Right. I think you dah terlebih ni. Right. You're not having. Right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Mana tadi apa? Kita bilang kira yang bawah. Serius? Ini. So cukuplah 24 kan? Okay, so tadi we are start with this, right? So apa yang nak buat? Jangan terus letak dekat sini lah. So what we are trying to do is to make it octet by taking one of the lone pairs. Right. And one common mistake is student often lupa. Kalau it is an ion, you need to write it as an ion. So how do you write as an ion? Is you make brackets. So bracket and negative. It means that this negative can be anywhere. It is shared across the molecules. Right? Okay. So now is the tricky part. Okay. Bersyukurlah tadi siapa yang dah datang lepas. Because now, susah. That we need to look dia punya molecular geometry. Nah, siapa pergi? Okay. Kau nak nombor siapa? Kau pergi. Tahu Adi. Aduh. Okay, siapa nak pergi buat benda-benda. So the first one that kau boleh pilih nak buat yang mana tu. This is the easiest one. Siapa? Kira kau buat. Kira kau buat. Sekarang lah kau nak pilih kau nak. Balik ni kita biar mahal lagi. Aiman, kami buat. Kau boleh sekarang kan? Okey. Okey. Nanti dia tak datang lagi. Pergi buat dia. Okay, okay, what we look for dalam UPT. Kita tengok bonding pair saja ke, kita tengok lone pair saja ke, atau kita tengok apa dia buat. Senyap jawab. So, apa geometry? Betul ke? Am I? Okay, if you think that's right, apa? And then now, okay. Cepat cakap, kena find. What I going to be my you nanti tu boleh je, boleh. Dalam ada silakan. Nak bawa saya dari belakang, dari belakang. Dan malam ni make sure you guys meet ni, okay? Kalau okay, dia datang dia. Ini juga kita share. Okay, 8 sampai 9. Pakai sini boleh. Tapi ada thing you guys unlock. So, kalau nak buat tu okay. Apa? Apa yang orang lain? Apa yang dia? Apa nama dia? Apa nak lain tu? Orang lain. Tak tahu pun. Beza. Mana pakai spider? Okay, nama ni. Tiga. Dan dia dalam three. Okay. So, jom discuss. Okay, correct. So, what determines molecular shape? Right? So, if we kalau nak tengok molecular shape, there are a few things that we tengok will influence the molecular shape. Number one is bonding pair. Okay. Another one is lone pair. Okay. These two will influence the pH. The total ni akan influence dia punya original shape. Lepas original shape, baru dah tengok apa yang jadi kalau dia ada lone pairs. Okay, so for example, this question, right? So we have how many electronic pairs? That's right. 2 bonding pairs, 2 lone pairs. So we have 4, right? So kalau 4, apa original shape? Apa nama makcik? Ya, it is tetrahedral. Okay. Tetra means 4. Hydro, there doesn't know here. Okay? So, it should be tetrahedral. That's the name original shape. Okay, so the bond angle is apa bond angle dia? Apa dia buat? Yes, 109.5. We have to have 0.5. Okay. But remember, we have lone pairs. Kita start cabut dia punya kaki. Cabut dia. Right? So this is dia punya shape. Nampak macam shape pun? Yes, this V shape. Right? So apa angle dia? Right? Okay. Cara nak tahu angle dia? Okay. So for example, I replace this with lone pairs. Okay, one of it with lone pairs. Right? Don't tak ada okay? Right? So what? All they can feel is the lone pair pushing down there. So apa angle dia sekarang? Less than 109.5. Okay, now saya tak puas hati lah dia orang tolak, tapi saya nak tolak lagi dia orang. Saya replace lagi satu dengan lone pairs. So ada dua lone pairs. So the force of tolakan lagi kuat ke lagi rendah? Lagi kuat kan? So they will be pushed. Yes. So macam mana tulis? Actually, so it is V-shape, correct? The angle is not correct. Okay. So the angle is 109.5 degree. And remember, kita buang one lone pair, it is less than. Kita buang lagi satu lone pair, less than lagi sekali. Easy as that. So this CS2. Okay. So apa yang kita tengok? Is bonding pair and lone pair. But only specific type of bonding pair yang kita tengok. Right? So we have 4 bonding pairs, right? 1, 2, 3, 4. Tapi this bonding pairs, what type of bonding pair? Okay. We have single and double bond here. Okay, this is double bond, right? Double bond compromise of sigma bond. Always it is. The very first bond is sigma bond. The second bond is pi bond. The specific characteristic of pi bond is it restricts rotation and it restricts molecular symmetry. Okay. So the only yang kita tengok is kita only tengok sigma bond only. So pi bond kita ibaratkan dia tadi. Okay? Because if you will tapi macam So bayangkan this is carbon. This is carbon, and we have apa punya ni? Sulfur. We have sulfur here. So what happened when kita buat double bond is we are making a new bond to some group. So this is just a representation lah. So if you look, the angle of this and this, dia tak letak macam ni. Okay, this is the physical restriction of this. Okay, so if you look, you will still be linear. So that's why pi bond kita consider it macam dia tak ada. even if the other. Okay? It just would not change the geometry. So if you look here, okay, tapi dalam Euclidean geometry tulis juga kan, pi bond. That is correct. It is linear and the angle is 180. Right? Even though dia ada pi bond. Okay, and now we are going to the last one, which is NO3 minus. Okay, even molecular geometry, make sure you tulis it as ions, right? And let's count how many bonding pairs yang kita ada. 1, 2, 3, 4. Tapi one of those are pi bond kan? Double bond. So we only have 1, 2, 3. So kalau 3 jadi bentuk trigonal planar plate. Kalau apa ada nak set plate? Planar. Okay. Name make sure because even though dekat, salah ejaan, dia punya jawapan ni salah. Right? So trigonal planar and the angle is 120. Okay. That's clear so far. Okay. Let me reiterate macam mana pi bond works. So any question so far? Korang pelajar-pelajar online okay ke semua? Tengok chat korang mengarut je. Okay. So korang okay ke? Dah catat ke? Saya nak padam. Korang catat? Korang padam? Pahala dari hari ni. Ya Allah. Yes. Okay, so now tadi I show you why pi bond tak affect geometry. Okay, so now let's look on very common molecules yang you guys hapus dekat hari. Okay, so if you did the Lewis structure semua, you will come into this. So this is the structure of carbon dioxide. Okay. So macam mana how in real yang dia boleh bend core yang sampai dia buat double bond. Okay. This is the molecule overlap. Macam mana dia punya electron overlap. Okay. So we have carbon. Okay. So carbon, apa dia punya electronic configuration? Tolong monitor saya. Carbon has berapa banyak elektron?
Sir, tak nampak sir.
Okay, dah. Kecil ni.
Kami dipinggirkan
Kamera
sir.
position dia.
Nampak tak? Nampak ke?
Tak clear, sir.
Tak clear. Sekejap
Nampak sir, jelas.
Tak nampak lagi tu saya dah tahu lah. Okay. Carbon ada berapa punya electrons? 8? 6. Okay, so dia punya electronic configuration is 1s, 2, 2s, 2, 2, 3, 2. Oxygen. Should ada 8. So electronic configuration is 1s2, 2, 2, 3, 4. Right? So we know in bonding, the only electrons yang terlibat dalam bonding is dia punya valence electron. Mari tahu saya which one is a valence electron. Mana satu valence electron? Ini je ke? Okay, valence electron termasuk dia punya shell. So you tengok apa yang last one? Okay, S2P and S2. So cari mana lagi ada dua? Which is this one. So this is in your valence shell. Same as here. Right? So carbon, we have so we have 4 valence electrons, and oxygen we have 6 valence electrons. Okay, which sit through dari 4 low pairs. Okay, so the orbital yang involved here is 2s and 2p. Right. So how actually the orbital overlap? Okay. So remember hybridization. Okay, hybridization. So carbon, dia ada 2s a fully filled orbital and we have a filled p orbital. Okay, tak penuh. Kalau penuh 6 kan? We have A is penuh. So we have 4 more empty. So realistically, carbon can only take 2 bonds, right? So dia ada only ada 2 available electrons. So what it did is ditukar jadi hybrid. So dia punya orbital yang terlibat is orbital hybrid sp orbital, right? Which is dia masukkan blender S dengan P, dia masukkan blender, dia tekan, dia kacau, keluarlah sp, right? So in this sp, we have one S. So we want to know how much. Okay. So sorry, salah. So we want to know what is the hybrid orbital. Is kita bilang berapa banyak yang dia ada connection. So carbon ada 1, 2, 3, and 4. So 4, it means dia perlukan 4 orbital. So mana orbital dia cari? Ya, kita boleh ambil satu S orbital. And then diperlukan lagi 3 orbital. Those 3 orbital datang dari P. Macam mana dia datang dari P? Okay. Remember S, bentuk dia is like this. But P, kita ada 3 kotak. That's why dia boleh ada 6. Okay, satu kotak only 2 electrons. So what we did is kita ambil here this kotak, this, and this, campurkan together, we have hybrid sp. That's why we have this. When bila kita dah excited state dia, saya cepatkan untuk masa nak habis. Kita dah excited state dia, every electron jadi single pair. Singly pair. Okay. While oxygen, okay, actually oxygen also happen hybridization. But in this case, kita tak perlu cakap dia hybrid. Just cakap dia buat two bonds and it's complete, right? Because kalau you tengok P orbital untuk P orbital untuk oxygen is we have 1, 2, 3, and we have 4 electrons there. 1, 2, 3, 4. Okay, actually they buat harga je, but this is just cakap they only use these two untuk buat bond. So, if you look, these two akan combine with these two, while the second oxygen akan combine with that. Okay. Macam mana dia do the combination? Okay. This is when we draw molecular overlap. Okay. Orbital overlap, sorry. So, sorry saya ambil masa korang sikit, lepas ni ada apa? Lihat dah. Okay, kejap So we have how to draw the molecular overlap. So we draw the central carbon first. Okay, so central carbon. We have sp3 punya hydrogen. Okay, apa shape dia? Macam mana nak tahu shape dia? Okay, tadi kita nak belajar pasal molecular symmetry kan? Completely based on that. Okay, kalau kita guna 1, 2, 3, 4, so shape dia adalah okay. So we have okay, ibarat like that lah. So better this one is the wedges dengan dashes tadi. Okay. And then oxygen. So mana oxygen? I'm sorry. Sorry. Okay, that's what I said. Okay. The real. Okay, kesian I'm not gonna baca. Okay, the shape is completely based on here. So nak tahu shape dia, is you only tengok sigma bond. Right? Tadi tengok sigma bond kan? The 1, 2 is linear. Right? So linear is you draw the orbitals like this. So we have 1, 2. Right? Mana lagi? Oh, sorry. Mana lagi 2 orbital? Okay, the other 2 orbital will be placed in the same side as p orbitals. Right? So, okay, oxygen, cara dia nak bond is use the p orbitals, right? So we have p orbitals. Okay, remember p, we have 3 type of p, sebab kita ada 3 axis, right? We have px, py, and pz. Okay, why it is x, y, z? Sebab dia adalah axis. So we can just indicate this as, cakaplah this one is z axis ataupun x axis. Right? Okay, those different color dia datang daripada oksigen. Okay, so on contoh px. Okay, so bayangkan that one is py. So bayangkan that one is py. Ada 1 orbital. Okay, so how do you buat the double bonds? Okay, the double bond datang daripada elektron yang ada dekat pz. Okay, so kita ibaratkan this one is pz. So we have. Okay. So how pi bonding works is there are overlap subways. Even though you nampak jauh, but actually it will mirror the fact. Okay. So this looks boleh overlap dengan this to make pi bond. Okay, so and also this can make the other pi bond. Okay, so kalau shape dari satu je. Okay. So imagine this is the carbon dioxide. So how do you avoid the sigma bond, which is overlap, is they don't overlap head to head. Okay? So they are macam head-on collision, accident dengan kepala di kepala. Right? So that is how they are what nuclear bonds. Right? So that and same as the other side. So that is your sigma bond. Right? Yeah. So as tadi dia overlap head to head, tadi, right? Dia overlap head to head, right? So it becomes one. So that is how I see in real world how close it is lah. So they overlap in. Okay. So that is union sigma 1. Okay. So how they work the pi bond is they overlaps side to side. So this one and this one. So this one overlap dengan this one. It was kiri and kiri like that. And this one to make the pi bond. So that's why they tak tukar any geometric punya shape. So once dia dah overlap macam ni, dia macam dah lock, macam awak lock gate awak. Dia tak nak rotate lah. Dia still will be linear. Even though dia ada time. Okay. So that's boleh ke? Ada any question? Okay. So, untuk hybrid, okay, you want to know how much hybrid in the world? Sorry, it should be SP2 lah. Okay, this one salah. Sorry, thank you for pointing out. It should be SP. That's a hybrid. Okay, so dia campur S and P. Even though sorry ya. Okay, saya betulkan balik ini. Thank you for pointing it out. Okay. So awak nak cari hybrid ni, is dia tengok sigma bond ni, right? Tengok sigma bond ni. So it is SP hybrid. And how dia punya bentuk hybrid? Okay, we only need two pair. So we need one S, and we need the P hybrid. So actually, dia punya hybrid is dia berpisah lah basically. So we have 1, 2. Okay. So the MTP of it. Okay, orbital P ada 3 kan? So dia only bergabung dengan sorry. Yeah. Saya pun dah terconfuse. So only ni. actually dia tak perlu buat edit to make the time. So dia perlukan fee. Okay, so this one nanti saya akan get back dalam Discord, saya akan hantar balik. So I'll make a drawing dan hantar balik on this part. Okay. So this one salah tepat. But the other one is correct. Okay. No, but okay. Okay, because now dah habis masa. Thank you datang kelas. Malam ni make sure you punya internet okay, because I takut kalau you start buat and the internet lost, dia tak pergi buat balik. So find a place untuk a good internet. And untuk yang orang online boleh masuk Discord. Boleh masuk Discord untuk ambil attendance.